In this lesson, we look at a type of function that is pretty interesting called a piecewise function, and it's defined by two or more equations. So unlike all of the other functions that we looked at that were just one equation, then we had the graph, this one is actually made up of two different equations. And if you see over here, there's this if statement. What that means is that x minus 2 is the function in the graph as long as the x values are less than or equal to 0. But if the x values are greater than 0, then this is the function that they're going to graph. And that's why the picture looks a little choppy, because less than 0, we have what would be the line x minus 2. If you extend it, that would be the line x minus 2. Greater than 0, we have the line 2x plus 1, and if you extend it, that would have been the line. But we only have portions of the graph. Now, it does pass the vertical line test of being a function because this dot is open and this dot is closed. So if you were to draw a vertical line down the 0 marker, it would not hit this value. It would only hit this value, which means that it wouldn't fail the test. So what they want us to do in example 1 is just evaluate the function, but if you're going to evaluate a function, you just have to pay attention to which portion of the graph you're looking at. So if x equals 0, which part of the graph are we going to be in? Now you can look at the graph or you can look at the equation, either one. But we're going to be in the x minus 2 section because 0 fits into the x is less than or equal to 0 section. So when we evaluate it, we don't do the 2x plus 1, we would only plug it into 0 minus 2, which would give us negative 2. But when we plug in 4, 4 is in the x is greater than 0 section. So that's going to go into the 2x plus 1. Also, it would be here on the grid somewhere. We don't know where that spot is, so we have to go to the formula. So you just plug it in, but you only plug it into the portion that it fits into, and that would be 9. All right, now let's talk about graphing a piecewise function, because that has a couple of steps involved. The first thing is the same thing that you always do. You make your xy axes. Then what you do is you look at where the graph starts to split, and that's going to be the numbers over here in this domain category. So this says that we're at the function negative x minus 4 when the x values are less than 0, and this says that the function is x if we're on the other side of 0. So what you do is you take your pen or pencil and you draw a dashed line down that spot. So I'm drawing a line down 0 to kind of remind myself where that splitting portion is. I drew it down 0. Now what you do is you want to make sure that you have a pencil with an eraser or an erasable pen or something like that. But we want to have something where we can erase. So what we're going to do first is just graph the line negative x minus 4, just like normal. So I go to negative 4, put my dot, and negative x would mean go down one, right one, and I'm going to go up one, left one a couple of times, and I'm going to draw my line. Now, what you do next is you decide which portion of the line you're going to keep. So what I'm doing is now I'm looking and it crosses the dashed line, but it's only supposed to be on one side of the dashed line according to the piecewise function rule. So which side am I going to keep? I'm going to keep the side that is less than 0. So I need to erase the portion of the graph that is greater than 0. So that's this section over here. So bye-bye. And then I also have to decide if that circle stays closed or it has to become an open circle. And since you're not allowed to be equal to 0 according to the equation rule, we have to change it to an open circle. So that's negative x minus 4. Now, as you get to be more experienced, you won't have to do the erasing, and you might not even have to do the dashed line, but at the newbie phase, I'm going to encourage all of you to do the dashed line and use the erasing portion. So then the next thing that we do is we go over and we graph the other function, which is just simply y equals x. Now that is a line that goes to the origin since there's no intercept visible and has a slope of 1. So you make that line. And then you also have to decide which portion of the graph you're going to keep. So I'm going to keep the portion that is greater than or equal to 0. So that's the portion on the right. So get my eraser out, and I'm going to erase everything that, whoops, it just erased my other one. I'm going to erase everything that is greater than, not greater than. And then I have to decide if that circle is allowed to be open or closed. And since I'm allowed to be equal to 0, it's going to be closed. So let me draw it back. And let me fix this other line. Now you can check and make sure that it passes the vertical line test by just kind of like imaginary drawing some vertical lines. And it does pass here because that's closed, but that's open. And now that graph is done. Last thing we have to do is describe the domain and range. So, like I told you, for the most part, for a while, the domain is just going to be all real numbers. The range, however, we do want to check. And what you do is you look and you see where there are no y values. So, is there a graph at this y value up here? Sure. Is there a graph at y values up here? Sure, because this purple line would extend. And there are portions of the graph all throughout as I scroll down the y-axis, except for when I hit here. And then there's nothing down here. So the y values have to be greater than this point right here because everything underneath this point doesn't exist on the graph. So that point right there is -4. And I'm actually not allowed to be equal to -4 because of the open circle. So the range is actually y has to be greater than -4. It's not even allowed to be equal to -4 because of that open circle. Example 3 has us doing the opposite. They have the graph and we need to give them the function. So here's how I would suggest doing this. All functions, all piecewise functions start off with y equals, and then there's that big open bracket like we talked about, the set notation. And then there are two equations right here, and then we would have the if x things over here. The first thing to start off is actually where it splits. So look at the picture and draw a dashed line down the point where the graphs change spots. That's right down here at 0 again. It's not always at 0, but I guess because we're beginners, they're putting all of our splitting at 0. So now let's leave a little blank over here. Let's leave space here for the equations, but we're just going to write the if statements. So if x, and now let's look at the first portion of the graph. This one has x is less than 0, and it also is not allowed to be equal. So that one's going to be x is less than 0. And the other one's going to be the opposite, x is greater than or equal to 0, because this is the portion that is greater than 0, and it's also allowed to be equal. Now we have to come up with the equations. So if it's helpful, and this is just an option, if it's helpful, you can extend the lines and see what it would be. Sometimes you need that to get the intercepts. This first line has a slope of 1, because it's up 1, right 1. And it goes through here at 0, 3. So that's the line x plus 3. Now let's go to the other one. This equation has a slope of 2, because it's up 2, right 1. And its intercept is right here at -1. So this would be the formula for the piecewise function for that graph. Last thing to look at is this thing called a step function, and a step function is a type of piecewise function that you will see as you get into high school math. And we call it a step function because it looks just like stairs, because it's defined by a constant value. And remember, constant is just another word for number. So we have just a series of line segments. And here's the equation for that. So it's 2 between 0 and 2. It's 3 between 2 and 4. It's 4 between 4 and 6. And so there's this like constant value that exists between the ranges. Let's make one. In example 4. You rent a karaoke machine for 5 days. The rental company charges $50 for the first day and $25 for each additional day. Write and graph a step function that represents the relationship between the number of days and the total cost of renting the karaoke machine. So we have got a couple of things going on. The first thing is that we're going to use a table to organize the information. So if you have anywhere from 0 to 1 day, and it's not allowed to be equal to 0, because if you're renting it for 0 days, then what's the point of this graph? So anywhere from the beginning of the first day to the end of the first day, it's $50. But as soon as you hit that second day, it's now an extra $25. And this is similar to if you've ever rented a red box. And what happens is Redbox movies are usually due by 9 p.m. So this is a little side story about a step function. Redbox movies are due at 9 p.m. If you go to that Redbox and you return it at 9:05, they're going to charge you for an extra day. So right when that hits that second day, that's why it's equal to X here, but not equal to X here, because as soon as you tip over into that second day, it's now an extra $25, which would bring it up to $75. And we're doing this for 5 days, so let's keep going. Each number of days section is going to look the same. Whoops, that's a 3. So that's 100, and then we have 3 is less than X, which is less than or equal to 4. That's 125. One more day. 4 is less than X, which is less than or equal to 5, and that would be 150. So there's my table, step 1. So now what it wants us to do is to write the step function. So we're going to take our table, and we're going to make that super long parenthesis thing. So f of x equals super big because we have so many, and it's just going to kind of be the reverse. If you remember that if x comes second and the equation comes first. So it's 50 if 0 is less than x, which is less than or equal to 1, 75. So as you can see, I'm just switching the chart to put the number first. Oh, whoops, I forgot X. Oh, wait, no, I don't need it because it's already in the category. Okay, so that's the step function. Now we have to take it and graph it. So let's scroll up a little. I'm going to move that over. Okay, there we go. So now we scroll up, and I actually don't even need that function. It told me to write the function, but you don't need the function. You can just graph using the table. I'm only going to be in the first quadrant because you can't have negative days or negative cost. And the scale is pretty easy. We can go by 1s on the x, and we can go by 25s on the y. So this is days, and this is cost. So I look here at the chart. It's going to be an open circle at 0.50, and it's going to be a straight line all the way to a closed circle at 150. So open circle, oh, let me change colors. Open circle, close circle. That's really big. And then I just do the same thing. So it's going to be an open circle at 175 all the way to a closed circle at 275, and then you just repeat for 5 total days. 1, 2, 3, 4, 5. All right, there you go. If you have any questions, write them down and ask me when you come to class.